Here we are for our third example of graphing a polynomial with the function h of x equals x cubed plus 3x squared minus 9x minus 27. And this is not in quadratic form, so we get to practice one of our other factoring skills. Again, I strongly encourage you to, throughout this video, pause it, see how far you can get, especially right now. Since this isn't in quadratic form, it's a nice way to test your recall on other modes of factoring. To get started as a partnership, though, recall that our first step is end behavior with our leading term, x cubed. Now, we know that the power is odd, and when the degree is odd, the end behavior is going to be the opposite on both sides. So if one goes up, the other goes down. If one goes down, the other goes up. Since this is positive, the right side is going to go up, which would mean the left side, being the opposite, would have to go down. So up in this corner, I'm going to label left down, right up. So when we're ready for it, we have the end behavior. Step 2, we're going to find the y-intercept. And our y-intercept is just our constant term. So the y-intercept is going to be negative 27. Step 3 is really where the heart of the problem is. It's where we figure out what's happening in the middle. So step 3 is our zeros, multiplicity, and graph behavior. So hopefully, if you paused the video earlier, you realize that this works well for factoring by grouping. So we're going to group and factor. So x cubed plus 3x squared plus negative 9x minus 27. Greatest common factor over here is x squared. So that's x plus 3 left inside. Greatest common factor from the second grouping is negative 9. So that's x plus 3 left inside. Greatest common factor from both parts is x plus 3. And then we have x minus 9, x squared minus 9. X plus 3, difference of squares gives us x minus 3, x plus 3. And notice that we have two of the same term, which means we can double up and write x plus 3 squared times x minus 3. Now, because I'm going to need this space, I'm going to write that all back here, x plus 3 squared, x minus 3. We're not really done with step 3, but we've now done the hardest part, which is finding the zeros. Now we just need to list them out. So our zeros, multiplicity, and our graph. From x plus 3, we get the 0, x equals negative 3, and then positive 3. I kind of do this somewhat unconsciously now, but notice that I did make sure I had my factors in such a way that my zeros were in numerical order. Multiplicity for our first factor is 2. Multiplicity for our second factor is 1. When our multiplicity is even, we get a touch, not a cross. And when it's odd, we get a cross. I do believe this might be the first case of getting a touch in our examples, just because of how things worked out. So now, step 4 is plot and label. So I need to obviously have to negative 3 and positive 3 on the x-axis. So 1, 2, 3. This is our negative 3, and it's a cross. Then 1, 2, positive 3. And this is, hold on, this is not a cross. This is our touch. Touch, cross. This is why it's important to have that written down, because it's really easy to jumble things up, especially when you have a negative and a positive. So be careful for that. And then end behavior is going to be down on the left up on the right, according to what we found at the beginning, and the y-intercept is negative 27, all the way down there. Again, the scale on our axis does not need to match if we're drawing this by hand. So I'm going to go down, and then since it's a touch, I'm going to come back through, and then our last 0 is a cross, so it's going to continue up. So we have down, touch, back down to our intercept, back up, cross, and then keep going up. And that gives us our graph. Again, if you want to put step 5 is actually draw it, you can. Oftentimes, I just kind of get pretty excited from the plot and label part and forget to label step 5. But if it helps you to think of it as a different step, by all means, I encourage you to do so. With that, I'll stop this video and make one more to wrap this up.